Hello everyone. Today we're going to talk about the adversary argument, and we're going to use this argument for finding a lower bound on the selection problem, on finding the largest and smallest numbers in given a set of numbers. So here's one example. Let's say that we have numbers S1, S2, S3, S4, and S5, and we don't know which one is the smallest one and which one is the largest one. So our opponent will answer us and will give us the as little as information that they can. So because we're looking for a lower bound, okay, so that's why they're revealing the smallest amount of information every time. So how it works is, let's say for this problem, okay, for the adversary, for the finding the largest and the smallest number, we are going to ask that if, for example, S1 is less than S2 or not, or maybe we can ask that if S1 is greater than S2 or not. And we are also assuming the values are distinct, okay? So, and every time that we are receiving some answers, let's say that we ask, okay, so the question is, let's say question 1. If S1 is greater than S2 or not. And the answer will be either yes or no. Okay, so one of the answers will be, but not both of them. So we'll have either yes or no. So, and we are also having some definition. Let's say that we are calling the winner, okay, in this comparison, the variable or the item that has the greater value, and the loser the one that has the smaller value. So based on this definition, okay, so here let's say that the answer is yes. If the answer is yes, it means that S1 is greater than S2. Then we call this S1 here, we change the status of S1 to win, and we are changing the status of S2 equal to L. And at first, both values, okay, are equal to some x. That means that the status of these two values are unknown. So we are not aware of their status. We haven't compared them with any other numbers yet. So at first, we start with x, okay, then we are comparing. So if S1 is greater than S2, and the answer is yes, so we change the status of S1 from x to win, and we are changing the set of S2 from X to lose or L. So and we can also get give some values to every information that we get. So when we haven't compared any value and we haven't asked any question from the person that knows the largest and the smallest numbers, okay, and they know the numbers. So the information x is equal to 0 value. So we don't know anything. So it has 0 value. Each win or lose information gives us one information, one value of information. So either W or L or lose. Okay, then we'll have one piece of information. And when we have, for example, some values that both are won some comparison and they also lost some comparison, we have WL that gives us two information. So when this happens, for example, assume that we have the question number 2 asks that if S1, this item or variable S1 is greater than S3 or not. And let's assume that the answer here for this question is no. So the answer is no. And before, so that was question number 1. Okay, we found that S1 is greater than S2, so we changed the status of S1 to W. And here, also the status of S3 was X. Now we compared it with the S1 that had the status W. And now the answer is no, so it means that S3 is greater than S1. So status of S3 becomes W, and the status of S1 becomes WL. And it means that S1 is, when compared with some other numbers in the set of all numbers that we have here, lost and also lost some comparison, also has won some comparison. So it means that so far we found that at least that S1 is not the largest number. Also, it cannot be the smallest number because S1 was already greater than S2, and also it lost to S3. Okay, so that gives us this information here that we have. So for example, if you want to like to see that and set like these values in some table, we're going to have S1 at first, S2, and S3. At first, we had this comparison of S1 is greater than S2 or not. And the answer was yes. Okay, so the answer was yes. And so we can have some initial value at first. So at first, all of them were x, and x here. And then we had this comparison here that if S1 is greater than S2 or not, and let's say the answer is yes. If this is the case, okay, we still do not change, we are not changing the status of this 3, okay, because we don't know about this item yet. But here we will have W, status of W for S1, and status lose for S2. So that was the first one. In the second one, the same question was if S1 is greater than S3. Okay, so now let's say the answer is no. And because we already know that the S1 had the status W, and now it becomes WL. We don't have any a change for S2, okay, because we haven't compared with any other node yet. But the status of S3 becomes W. So that's, for example, how we can continue, and we're gonna do some example of these numbers later. But keep it in mind that when we are talking about asking questions, okay, the assumption is that the answers are always consistent with each other. So it means that our opponent, or the person that gives us the answer doesn't lie, or doesn't give us the false information. So this assumption is necessary to build this theory about the finding the lower band on the finding the smallest and the largest number. So yeah, so it means that for some reason the status of for example S1, when we found that S1 is here, that's what we found so far, that S1 is greater than S2, but it's less than S3. So it means that if later we ask, for example, S3 is greater than S2 or not, okay, then the answer cannot be no. Okay, the answer cannot be no, because it's gonna be inconsistent what we learned so far. Okay, so the answer must always be yes, and because of what we had so far. So here we have this one, there is no change on the status of the S1, the S2 still is loose, and the status of this one is still L. So do you see that what's happening here? We ask a question that doesn't add any information to us. Okay, so we said that any W or win or lose gives us information of 1, or WL gives us information of 2. But here, as you see, there is no change in status of any of these values that we had. So this question that we had is actually a useless question, okay, because we already were able to convey some information based on the previous two comparison. Okay, so we are going to avoid this question, and always we're asking question that at least gonna give us one like one piece of information, or either like those ones that haven't compared yet. Okay, so we are gonna now see that how we can we are gonna do some example, and later we are gonna see that what's gonna be the lower band on selection problem when we're gonna find the smallest and the largest number. Now let's see how this adversary argument works with these five numbers S1 to S5. Assume that first we are comparing or asking that if S2 is less than S1 or not. Let's say that our opponent, like the adversary, says that S2 is larger than S1, or the answer is no. So the answer is no. It means that S2 is greater than S1. So here, what we're going to do is, beside the states of each variable, each value, like variable S1, like to S5, we are going to also assign some values to them. Okay, and it's going to help us for like seeing that how these this adversary argument works. So what happens is the S1 lost the argument, like the question. Okay, so lost the comparison with S2, so its status is L. And let's say we just assign some numbers to that. Okay, let's for example assign number 10, and S2 was like the winner, so its status becomes W. But now we need to, for example, assign also a value for S2. And because S2 was greater than S1, so definitely the value that we're going to assign to S2 will be greater than 10. So let's say, for example, we are assigning number 20 to S2. And also the status for S3, S4, and S5 doesn't have any changes. And how much information we gained? First, like S1 and also S2 were also X, and now we have two pieces of information. So the unit of information that we learn is equal to 2. Next, if we again, like for example, compare that if S2 is greater than S1 or not, okay, will give us the same result, that the winner is S2, and there's a loss for S1 and the win for S2, but it doesn't give us any new information. Okay, so the unit of info that we're going to learn, again, if we are checking that if S1 is greater than S2, will be 0. So we are not going to do that. Instead, we are going to check that if S3 is less than S1 or not. And let's say that the answer to this question, that if S3 is to S1 is no, so it means that S3 is the winner. So what happens? There is no change on the status of the S3 because there is no win so far for this one, and still there is no change in the value of S1. Okay, because we haven't found some smaller number and like the S1. So there is no change on S2. Okay, still is win with the value 20. And we are gonna give a status of W to S3, and for now, okay, we are gonna just give temporary a value of 15 to S3, and there is no change for S4 and S5, so it's gonna be X for this one. So how many information we learned here is 1. Okay, there was no change in the status of S1, so there's no new information here. Okay, no information here, but we have one information here. So the units of information that we learn is equal to 1. Now, why I wrote these like the value of S3 equal to 15, because we are not sure about like the comparison between S3 and S2. We don't know which one is larger, so we need to figure it out. So now let's do the comparison. So S3 is greater than S2. Let's do this check. And let's say that Our opponent says that yes, S3 is greater than S2. So what happens? There is no change on the status of S1 because it's not. There is no change, no new information about S1. Now because S2 had lost this comparison to S3, its status will change from W to WL. So it means that it already won a comparison and already lost a comparison. So here, what we found so far is that S2 cannot be the largest number or the smallest number because it has the win and lose. And so something that I think I forgot to mention that for finding the largest number and finding the smallest number, we need to see that what's going to be the final status of the values that we have. So if a status of a variable or an item is win at the end, okay, it means that it's the largest one. And win, we said that is the result of comparison of that number with all other numbers. And the smallest number also is the one that its status is equal to lost, okay, not WL or the win lost, just lost. It means that it's smaller than any number and it hadn't won any comparison, so it should be smallest. So that's why we are saying that like now S2 cannot be the largest or the smallest number. So here we are gonna have the value of 20 for S2, but because now we found that S3 is greater than S2, okay, we are gonna assign a new number, okay, to S3. And while we are changing the values, okay, as we said, this value is going to help us like to do some analysis on the things and help us gonna like to understand this example better. Okay, we don't need to assign numbers and values to these variables or items, but it's going to help us. So far we found S3 is greater than S2, so the value of S3, okay, might be is definitely greater than the 20 because we said that let's assume that the value of S2 is equal to 20. So here gonna be win, and here we're gonna, let's say for example, we're gonna assign number 30 to this one. And also there's no change on the S4 and also S5. Okay, so there's no change here. And the information that we learn, okay, is here. So we learn this information here. So I'm gonna show it with the red line here. So one information we learn here and one information we learn here. Okay, because there's no change in the status of the S1 and S3, and we have one in the status of S2. And why not 2 instead of like 1? Because okay, we had already known about its winning condition. Now it became the win and loss, so we only have one piece of information added to our our knowledge, not 2. We only know that S2 now also has a loss. So the next comparison is S4. So we're gonna look, for example, now we know about the S3, S2, and S1 so far. So what's the status so far? That is S1 is less than S2 and is less than S3. We assign number 30 to S3. We assign number 20 to S2. We assign number 10 to S1. So that's what we learned so far, okay, with asking just these 3 questions. Now we're going to ask the next question, that is, what's this between S4 and S1, which one is the largest? And let's say that here our opponent says that the S4 is larger. So here between S4 and S1, okay, still there is no change on the status of S1 because it was lost and it still is lost. So there is no change on the status of S1. Okay, so lost and 10. So there's no change in the status of S2, okay, because we haven't compared and we don't know anything new about that. No change on the status S3. And now S4 has a winning status. So a winning status, and still there is no change on the status of S5. So as you see here, the only new information that we got is here when we found that S4 now has a winning condition, winning status. So the amount of information that we got, okay, is gonna be 1 unit. Sorry about that, it's moves. Okay, so it's gonna be 1. Now, so we have like we have 5 information so far. So we have learned 5 amount of information. Now the next comparison, okay, is gonna be with S3, okay, it's with the largest number that we had so far. So we're gonna compare S3, S4, and S3. And also let's assume that between S4 and S3, S4 is the larger number, so it's gonna be S4. Okay. So one thing also I forgot to assign some value for S4 here. Okay, because S4 is greater than S1, its value must be greater than 10. So we can again assign some value, for example 11 maybe. We're gonna assign number like 11 to S4. So far we have for example something here that S4 might be here. Okay, we are not sure yet. Okay, we are like the puzzle is not complete yet. So now we're comparing S4 with S3 to see that what's the relation between these two numbers. So S4 and S3, S4 was the winner, so no change on the status of S1, no change on the status of the S2, and now the S3 becomes also a loser. So what happened is that here we need to change the status of S3 to win-lose. Okay, so it's gonna be win-lose, and with the value that 30 it has. And because now we found that S4 is greater than S3, okay, we are gonna assign some value greater than 30 to S4. So we are gonna give a number, let's say 35 to this S4, and also we are gonna there's no change on the status of S5. So how many pieces of information we learn? It is still 1, so no change here, and the only information that we got is here that S3 now here lost their things. I'm gonna like do this division, so okay, I think it's a little more readable here. So that's like the information so that's the change that we have. So the amount of information we learn gonna be 1 here. Okay, now we found that S4 is also greater than S3, so we are going here, and okay, we know that S3 is less than S4, and let's say we assign a number 40 to S4. So that's the information that we got so far. Now the next one is S5. So we are gonna check S5 with the smallest number here, that is S1, and then we're gonna, if it's smaller than 1, then we are gonna like to make it the smallest one. So here comparison of S5 with S1. If S5 is less than the S1, if it's smaller than this S1. So here let's assume that S5 is larger. So what happens, there's no change on the status of the S1, no change of the status of S2, no change of the status of S3. no change on the status of S4, and here we have a win condition for S5. And it's still, because we don't know about the value of S5, let's say we are, for example, we are going to assume a number 12 to this S5. And we got another piece of information. So here, that's where we got the new information. Now, we found that S5 is not the smallest one. Now we're going to compare it with the largest number, that is S4. So S5, if it's larger than S4. And let's say the answer is yes. So S5 is the largest one, and there is no change on the status of S1, so 10, S2 WL 20, W3 is going to be also 30, W S4, because it has a winning condition before and now lost to S5, so it's going to be WL, and let's say it was for 35, and now S5 was winner, and we do not change its status. But now that it's greater than S4, so we are gonna, for example, let's assign another value. Let's say 40, 40 to this number. Okay, so I think I made a mistake here, so I'm gonna change this one here to 35 here. So we assign 35. And now, look, if we are done with all the comparison, if you'll see, all of them now has the status. So S1 is the status like L. All other numbers has the status winning and loss. So it means that they are somewhere between the largest number and the largest number. And S5 has the winning condition, or like the winning status of W. So we can conclude that S1 is S1 is the smallest number, okay, and S5 is the largest number. And also going back here and add this one, that S5 is the largest number, let's say with value 40. Okay, and again, we don't care about the value of S1 and S5 here. We just, by asking some questions, okay, let's say how many questions, 1 2 3 4 5 6, with only asking 7 questions, we were able to find the answers for to finding the smallest number and the largest number. Next, we're gonna see one theorem about using the adversary argument to do the selection problem of the smallest number and the largest number. That's a theorem. So it says that any deterministic algorithm that can find both the smallest and the largest of n keys in every possible input only by comparison of keys must, in the worst case, do at least 3n divided by 2 minus 2 comparison if n is an even number, and 3n divided by 2 minus 3 divided by 2 comparison if n is odd. And now next we're gonna prove this theorem. To prove the theorem, we need to see that how many units of information we need to learn for finding the smallest number and the largest number. So this algorithm needs to know that when we are saying that the smallest number, it means that all other the keys, okay, at least have one comparison. And for finding the largest one, it means that all other the keys or the items that we are comparing at least should have lost one comparison. Okay, so it means that we need to have n minus 1 the win for the smallest one. Okay, for finding the smallest one, it means n minus 1 lose for the largest one. So together, that's the amount of information that we need for just finding the largest and the smallest. So that is equal to 2n minus 2 unit. Again, so we said that for finding the smallest, it means that all other n minus 1 items or the keys that we have should at least one comparison. So it is n minus 1 piece of information. And for the largest one, also all other n minus 1 must at least have lost like one comparison. So n minus 1 plus n minus 1 going to be 2n minus 2 units. But now let's see that how much information, okay, we can get by comparing, okay, because we're going to see what's going to be the number of comparison that we require. So as you remember on the example that we did, okay, at first all the items had no status, or their status was unknown. So when we are comparing a number with another one, so we are getting like information. And because we have n numbers, okay, the number of comparison when they are all of the numbers, okay, at first all of the numbers have the unknown status, then we have n divided by 2 comparison, okay, n divided by 2 comparison to give us like the information. So each comparison, so that's the number of comparison, okay, number of comparison. And each comparison will give us 2 pieces of information when both both keys, okay, in each pair hasn't had any status before. So it's gonna be 2, okay, so that's the unit of information. Together it's gonna be n unit of information. So as an example, let's say we have S1, S2, S3, and S4. Okay, and we are gonna like to get some information, and all of them for now have the status X. Okay, let's say for example we compare S1 with S2, and for let's also S3 with S4. So we are gonna get 2 pieces of information here and 2 pieces of information here, and the number of comparison is n divided by 2. So n is equal to 4, and the number of comparison is n divided by 2. It's 2. And the amount of information that we're getting is 2 multiplied by n divided by 2, that is equal to 4. And as you see, for example, let's say S1 is less than S2, so it's going to be L. This is going to be win. And let's say S3 is not less than S4, so it's going to be win for this one, and this is going to be lose for this one. So we have got 4 information. And now let's see that how much information that we need to learn. So we had totally 2 n minus 2 unit of information we had to learn to find the largest and the smallest one. At first when all of the numbers or items or the keys has like unknown status, or so we can get in like unit of information. So that's gonna be n minus 2 information. So n minus 2 information now remain. Okay, so for this n minus 2 information, we need to do another n minus 2 comparison. So we had the n divided by 2 comparison here, and another n minus 2 comparison. So the number of comparison will be n divided by 2 plus n minus 2. That together this is gonna be equal to 3n divided by 2 minus 2 as the total number of comparison that we need to do, or the at least total number of items that we need at the worst case. For a similar proof for when n is an odd number, you can see my previous video on the same problem, the selection problem. That we showed that it's really easy to do that. Okay, again, you can, for example, assume that like you can do the analysis for n minus 1 items that is an even number. Then you're gonna like to add the number of comparisons required for that one number or item that is remained, and you can just sum up the number of comparison and you will reach the same number. But for more information, you can check my previous video on the selection problem.